So let's take a look at some of the key takeaways here from this particular lesson. The first is that we can evaluate one-sided limits using the notation very important here. The limit as x approaches c from below of f of x for values to the left of c. Whatever value I want to know as x is approaching, this little minus sign again notes that we're looking to the left of c, and we can also use the notation the limit as x approaches c from above of f of x for values to the right of c. So this idea of one-sided limits, we can make these statements about where a function heads from a particular direction. In order for the limit to exist, so if the limit as x approaches c from below of f of x equals L, and that also happens to equal the limit as x approaches c from above of f of x. So in other words, if they're headed to the same place from opposite directions, that's when we get to say the limit as x approaches c of f of x is in fact equal to L. And then we looked at a couple of instances where a limit might not exist. So some of the main cases where you'll see where a limit does not exist. One of the main things that can happen is the one-sided limits don't match. We saw that with the function the absolute value of x divided by x, where we were headed to -1 from the left and we were headed to +1 from the right. We were going to different places, and that meant that the limit doesn't exist. We also learned that the limit might not exist for functions that are unbounded. Now that we might use our limit notation to describe the behavior in terms of heading to positive infinity or negative infinity, but in order for the limit to exist, it has to be headed towards a finite number. And then the last case, a kind of a very peculiar case for limits, is whenever we have functions that oscillate near whatever that value of c is. And we saw that with the sine of 1 over x. As we got closer and closer to 0, the function just kept bouncing more and more rapidly between -1 and +1. It never headed towards a singular number, and so that meant that the limit doesn't exist. And so these three criteria are cases where very oftentimes you'll see where the limit doesn't exist because of one of these three types of behavior.